Welcome to a lesson with Dr. Powell. Let's take a look at an example using L'Hopital's rule, where the top of a fraction is headed towards 0 and the bottom is as well. For instance, let's take this one. For x squared e to the x all over cosine x minus 1. Notice when we plug in 0, the top goes to 0, and we plug in 0, the bottom goes to 0. Now, when you're using L'Hopital's rule, always make sure to check this. And if you're writing things out, write this out. At the top, at least show an arrow that you understand that the top is going to 0 and the bottom is going to 0. And then you can go ahead and use this rule. So let's get going with this rule since we know we can now use it. Okay, so we say this is equal to, then we write down limit. And then on this fraction, we simply take the derivative of the top and then we put it on the top. So now here we'd use a product rule, 2x e to the x, or a box rule with 2 boxes, plus x squared e to the x. On the bottom, we take a derivative, we get negative sine x. Okay, now the limit as x goes to 0, so these two limits should be the same. Great. Now let's see if we can plug in 0, and notice we can't. We get a 0 on the bottom. On the top, we actually end up getting 0 again. So you know that it's going to 0, 0. So guess what we can do yet again? We can actually use L'Hopital's rule again because we have the same setup, top going to 0, bottom going to 0. We know these limits are equal. And maybe if we do it again, we might actually get something where we can plug in. Let's try it. The limit as x approaches 0. So on the top, we have a product rule and another product rule there. So in turn, we have 2 e to the x plus 2x e to the x. Over here, we have 2x e to the x plus x squared e to the x. And then on the bottom, the derivative of a negative sign is negative cosine. Plug in 0, and you notice the bottom is now negative 1. Hey, that's great. Now we can plug in. So the bottom's negative 1. The top looks like all these guys over here will be 0 when we plug in 0. But this one right here will actually be 2. So it looks like our limit is negative 2. Thanks for watching.